Hello and welcome to the second part of a very interesting video. So this is the second video that deals with this microphone preamplifier and amplifier. And this is not mine, I got it from a friend who wants it repaired because he is part of a band and he wants to use it in his band. So as mentioned in the first part, he wants to use it in his band. The band is called Half Baked Cheese. So if you want to see this thing in action, then check them out. In the video description you can find some links to their pages, so check them out. And in the first part we evaluated what needs to be done to get this thing working again. So I've checked the different components and evaluated how expensive it would be to replace the components and so on. And I told him that, and he agrees, he wants it repaired, and therefore this second part now comes up, in which I will repair the thing. So again, check out the first part if you haven't watched it, because in the first part you can see the detailed analysis of this thing, what needs to be done to get it working again. So if you're interested in that, check that out. But now back to this second part here. And as you can see here, I've already ordered the components, so the components have arrived. So we have to replace capacitors, and there's also a tube which has to be replaced in here, because we've checked it with the tube tester and one tube was completely bad. So we have this tube here. Yeah, so let's get right into it. So I already did a little bit, I already cleaned the potentiometers. Then I already cleaned this power switch here. I have disassembled the power switch and cleaned the internals and then assembled it again, because it's a very important switch. And I've checked it with the multimeter, and in the on position it was not completely at 0 ohms. So I disassembled it, I cleaned it, and now it's perfectly conducting. And I've also replaced the broken fuse, or the open fuse, because we had a blown fuse in here, if you can recall from the first part, and I've already replaced this. Okay, and now we have to replace the capacitors and do some other things. Okay, alright, so where do we start? I would say that we start with a very important safety point, which I haven't mentioned in the first video, and this is the line filter. So what is the line filter? The line filter is something that prevents EMI from coupling into the device via the line plug, and it also prevents EMI to be emitted from the device back to the power line. Okay, so EMI means electromagnetic interference. So this is interference that the device could cause, or interference that could couple into the device. So line filter is an important thing. But it is also very safety relevant, because in the line filter you have a capacitor connected between your hot and neutral. So if this capacitor shorts, then this is not a good situation, of course, because then you short your hot and neutral. So this capacitor definitely shouldn't short, okay? And you have also connected a capacitor between your hot and chassis and between your neutral and chassis. And this is even more dangerous, because if a capacitor that is connected between hot and chassis shorts, then your chassis gets hot, and then you have a dangerously high voltage on your chassis, and this is of course very dangerous and shouldn't happen. If you have an RCD installed, then it might detect this, but we don't want to take the chance. We definitely don't want to take the chance. So therefore these safety relevant capacitors have to be replaced for sure. So if you work on a device like this, this might be the most important safety thing, to replace these line filter capacitors. So since they are special capacitors, they have to have a special rating, and this is X and Y rating. So capacitors which are connected between a line and neutral are X-rated capacitors, and capacitors which are connected between a line and chassis, or neutral and chassis, are Y-rated capacitors. Okay, So these are X and Y rated capacitors. You can find a lot of information about them online. So research a little bit about this, because this is a very, very important safety concept. Okay. Yeah, so let's get right into it. Let's check out the line filter of this thing first. So let me rearrange things so that you can see it. Okay, alright, so here we're looking at the line filter right next to the mains transformer. And here we have the input of the line filter, which directly connects to the mains input of the device. And then here we have the output of the line filter, which goes into the fuses and the power switch and the rest of the device. Okay, and where are the dangerous capacitors? And actually the dangerous capacitors are all in here in this thing. So this thing contains multiple capacitors. It contains capacitors between hot and neutral, and it contains capacitors between hot and chassis and neutral and chassis. So multiple capacitors are in this thing here. So this is our dangerous thing, and we have to replace it either with separate capacitors or with one capacitor that has the same properties. So first of all, I will remove this line filter here, and then we can take a closer look at it, and we will replace the safety relevant capacitor or capacitors. Okay, alright, so here we have the line filter, and this is our dangerous capacitor. And as you can see, that we have a capacitor here which is in between hot and neutral. So here we have one capacitor, and if you look carefully, then you might also be able to see that we have here a capacitor which is between hot and chassis, because the whole capacitor is mounted on the chassis. So this whole capacitor body is chassis, and then we have also here a capacitor between neutral and chassis. Basically it depends at which way the power plug is plugged, so which side is hot and neutral. But anyway, one of this side will be connected to will connect hot to chassis. So this can be very dangerous. So we have to replace this. And first of all, let me unscrew it. It is just held via screws here. So here we take a closer look at our capacitor, and you can clearly see that we have a capacitor between hot and neutral, and there are also two capacitors connecting the chassis with hot and neutral. Okay, so these are the Y capacitors here, and this is the X capacitor. So we have two Y capacitors and one X capacitor in here. Alright, so I will have to unsolder this and find a proper replacement, and of course I already have ordered a proper replacement, and this is this thing here. So this is an X1 Y2 rated capacitor. It has the same properties. It has 0.1 microfarad in X. So this is this thing here, and it has 2400 picofarad as Y capacitor, and these are these two here, and here we have 2500 picofarad and 2400 picofarad is close enough, of course, so we can use it. And I've ordered it because it looks pretty similar to this one, so it's easy to replace it. And does the hole also fit the screw? Yes, it does. So as you can see, I can screw it right away in here, and it should be a good replacement for this thing. So yeah, first of all, let me unsolder this one because it's soldered onto here. So let me disconnect this, and then I will insert the new one. Okay, so here we have desoldered our line filter capacitor, and we will replace it with this one right here, right now. But before we do that, let me just check this one. I will just check it with my capacitor tester because I'm curious how it checks and what it does. Again, you have to replace it for sure, but I'm just curious what it actually does if it is checked with my capacitor tester. Okay. Okay, alright, so here I've connected the line filter capacitor. So now the X capacitor is connected to the capacitor tester, as you can see. and I've set it to paper mica, and now I switch it to the leakage mode, and I will increase the voltage. And as you can see, it's already leaky at 100 volts. So this is something that you definitely don't want. If I switch it to electrolytic, it will test good, but in paper mica it is already leaky. So we have a leakage between hot and neutral here, which is not good. And now let me check it between hot and chassis. So first of all, of course, put it into discharge, into the maximum voltage. And now let me connect it the right way. So we have to, so now it's connected between hot and chassis, so to speak. And let me put it back to leakage. Okay, not good. At 150 volts DC, by the way, this is DC of course, we have already leakage. This is not good, so we have leakage between hot and chassis. So this capacitor definitely has to be replaced. And it also has to be replaced if there is no leakage measurable, because you cannot guarantee that such an old line filter cap is safe, okay? So you have to replace it. Doesn't matter how good or bad it tests, always replace this thing, okay? Okay, and now I've replaced the safety capacitor. So here we have the new XY capacitor in the circuit. Since this mounting screw, which is here, is not in the middle, the capacitor has a little overhang here, but this is not a problem because there's enough room in here for the capacitor. So this should work fine. And one note here is that the connections of this capacitor is a little different than the connections of the original one. Actually, the input, so to speak, is this side here, okay, and the output is this side here. So it's not like the original in parallel, it's this input-output thing here, okay. But otherwise, from that, it should behave the same. And as you can see, to connect it with this inductor here, I've used heat shrink to isolate this, which is very important so that we don't short anything. And here I've also used it to make this cable a bit longer here. And then it goes into the output of the line filter, and then it goes right into the rest of the device. Yeah, and so now this line filter is safe and ready to use. Okay, alright, so now it's time to replace these big capacitors here. And there's one important thing to note with these two here, and this is, as you can see here, they contain 2 times 32 microfarad. So there are 2 capacitors in here, 2 32 microfarad capacitors are inside these capacitors here. So therefore they have actually 2 plus for these capacitors and 1 common minus for these capacitors, okay? And these 2 here have only 1 capacitor inside, so they are simpler. And what do I have for replacement? For replacement, I've ordered these special capacitors here, which look quite similar, but they are smaller, of course, because electronic involves, and therefore the stuff gets smaller. And what you can see on here, they have also 32 plus 32 microfarads, so which is exactly the same that this one has. And how is it connected? Basically, we have these 2 pins here, and these 2 pins are the plus of the capacitors, and then the housing, and this tab here is the common minus, or the common ground of the 2 capacitors here. So this is the way how we hook it up. And another note here is, of course, that the voltage rating of the replacement cap should be the same or higher than the original cap, so that you make sure that you don't destroy the new capacitor with a voltage which is too high. Basically, in this case, I think this is rated for 500 volts, and I think the voltage is much lower that this capacitor has to store. But anyway, if you want to be safe, then always use the same or a higher rating, which I did in this case, of course. And I also have a replacement for these small capacitors, and it is this here. So this is also a good replacement. It has 550 microfarad, which is the exact same value, and it has only one capacitor in it. So we have these two pins here, which are the plus and minus, and of course these are electrolytics, so we cannot swap plus and minus because then they will explode, and this is something that we don't want. And therefore here it is also noted that plus is the pin number 1, and pin number 1 is this one here, so this is plus. Okay, and where do I get such replacement capacitors? Actually, I purchased them at Frag Jan zuerst, and this here is their homepage, so you can check them out, and there you can get such authentical replacements like this. So I really like using them because they look quite similar to the old ones, and therefore it's a good drop-in replacement. Alright, so but let's get right into replacing these capacitors. Okay, so here we're at the bottom side of the thing, and this here is the bigger 32 plus 32 microfarad capacitor, and here we have the smaller 50 microfarad capacitor, and as you can see there are two wires coming out of here, so this is a plus and minus, and here with these 32 plus 32 we of course need 3 wires, so we have 3 wires coming out here. So we have this black one, a green one, and a red one. There we go. So since the new capacitors don't have any wires on them, I have to solder wires on these pins here, of course, but this might be a simple task. Yeah, so first let me desolder this capacitor. So this is the 32 plus 32 one, and here is this is the common minus of the capacitor. So there we go. So this was the first. And then we have 2 separate pluses, and this here is the first one. So but this is a bit in the way here, so I will remove this one first, and now I can remove this here. There we go, and I can remove the other one here as well. Okay, alright, so the thing is now desoldered, and now I should be able to remove it. So I have to open it up here. Okay, so now it's loose, and now I should be able to remove it. So carefully take out the wiring here. And there we have our old capacitor removed. So this was our 32 plus 32 microfarad capacitor. And here you can see the wires, so I can remove that. And here this was the common ground, the common minus, and these are the separate plus, so the red and the green one are the separate plus poles. And now I have to insert the new one, and I have to solder wires onto it so that I can reconnect everything. Okay, alright, so let's mount the new capacitor, and one question which arises is how do I connect the ground of the capacitor, because the old one has 3 wires and this one has only these 2 and the housing. And I will do it as follows. I have this ground connection here, and then I will screw it on here, of course, and there are conveniently there are some holes here, and here under here there is also a hole, and I will use them to put this wire through and to get a ground connection that way. Okay, so let me do that. So first of all I will mount it here, and yeah, so, and I've measured it, so everything here is ground, so I don't have to isolate it. Okay, so now I've mounted it on here and I've measured it. This whole thing is ground, so I don't have to take care that the capacitor is not touching this thing, so this is not a problem. And now let me get the ground wire through the hole, and there we have it. So here we have our ground wire, so there it is, and I will route it the right way through here. So there we go, And here we have it. This is our ground wire now routed through here. So next I will put it through this piece, because this is how it was assembled originally. And there we go. So now we can solder it back to where it was before. Okay, so this one was also connected to the same point where the ground was. So we can solder it carefully to where it was. Okay, so now I've removed the old solder, and here the wires are in the right position, and now with some new solder I will solder it onto here. So there you have it, and now I will continue with the plus poles, and for this I will use red wire. These are both the same, so I can use either of those for both sides, and so this should be the right length. Okay, alright, so I've soldered this plus wire from here to here off camera, and now I will do the second one with the camera running. And one important note here is that you don't make these wires too long, because if these wires are too long, then the thing can become unstable. So you don't want that. With unstable I mean it can break into oscillation and such stuff. So it has to have proper high frequency properties, and therefore you want short wires. So let me put this wire through here. There we go. Here I can see it. So there we have it. And now next let's put it through the hole in these capacitors here. Okay, and now I apply solder to make a solid connection. Good, everything is soldered into place, and now I have to connect the other side. So I have to get it through here. And there we have it. So now this has to go onto here. There we go, and now let's solder it. Of course I've removed the old solder first. Alright, so this should give us now a solid connection right here. Looking pretty good. Yes, it does. Okay, alright, so now I finished mounting and soldering this capacitor, and now I will continue with the others, and then I will be right back. Okay, so now I'm done with the big capacitors. If we look down here, you can see the old capacitors. So here we have the big ones with the 32 microfarads, with 2 times 32 microfarads, and then we have the smaller ones with the 50 microfarads. And as you can see here, we have one new capacitor connected. And if we look up here, this is the capacitor which we connected together, and here is another one with 50 microfarads. So let me zoom in so that you can see how it is connected. So here I've soldered these wires directly to this, and then they go where they should go. And again, use short wires. This is always important. So let me go down here. Here also I've used short wires to connect them, and up here underneath here there's another capacitor which I have connected here, also with short wires, of course. And now let me show you the top side. Okay, so here we're looking at the top side, and now it looks quite different because of the smaller capacitors. So they need less space than before. So for comparison, here we have the big old capacitor, and this is the replacement. So it has it's much smaller now, but they have the same or even better properties than before. So the replacement of these capacitors is done. Okay, alright, so let's move on with these capacitors here. We've measured them in the last video and we found out that they are leaky, and this, for example, was almost a short, so we have to replace them. And here I have the proper replacement. And one note with these capacitors is that they are not polarized like electrolytic capacitors, because if you reverse electrolytic capacitors, then something very bad happens. This is not the case with them. However, they have this marking here on one side. As you can see, there's a marking on one side. And what does this mean? This means that this side is the outer foil or the shielded side of the capacitor. So basically it means that this pin here on the capacitor is connected to the outside of the capacitor, okay? This side here is connected to the outer side of the capacitor, to the outer foil of the capacitor. And this can be important because this is then susceptible for interference. Interference can couple in over the body of the capacitor, via the body of the capacitor, and then the interference will be present on this pin, and not very much of it will be present on this pin. So it makes a difference how it is mounted, okay? And this means for us that in some devices this can be very important because it performs better, or maybe it could even start to oscillate if you mount it the wrong way. So we have to make sure that our new capacitors are mounted in the right way. And unfortunately, these new capacitors don't have any markings on them which tells you where the outer foil is. So this is not a marking, it's just you don't know. So we have to measure the outer foil side. And I've already made a video about that in detail, how I do it. And please check out this video if you are interested. But now I will do it very quick with this capacitor, and I will mark the outer foil on this one and also on the others which I will use to replace these capacitors. And then I will continue. Okay, alright, so here we are the outer foil test setup with my oscilloscope, and let me first enable bandwidth limitation, okay? And to find the outer foil is very simple. Basically, here I just have connected the capacitor directly to the oscilloscope, and now if I touch the capacitor without touching the leads, you can see that I couple in some interference, and now we have some interference present on the oscilloscope screen, okay? In this case 50 Hertz, and if I touch my lamp, for example, which is here near, then it gets even bigger. Right, okay, and now if I reverse the capacitor, and now we have less interference even if I touch the lamp. So the amplitude of the interference now is lower. Okay, so what does this mean? So even if this here now has lower interference, then this must mean that the outer foil of the capacitor is connected to ground here, because then it just then just all the interference goes into ground and not so much directly to the plus or to the signal lead of the oscilloscope. So now in this case, as you can see, we have not much interference going on, even if I touch the lamp here. If I reverse it again, we have much more interference going on. And therefore you can see, so even if I increase to the next voltage scale, we have much more interference going on. So clearly this pin here must connect it with the outer foil side of the capacitor. So we found the outer foil, so this is the outer foil side. So the interference you can see on the oscilloscope is bigger if the plus lead or the signal lead of the oscilloscope is connected to the side where the outer foil is. Okay, and it is smaller if the plus is connected to the side where the outer foil isn't. Okay, so therefore this must be the outer foil side, and now I will mark it. Don't forget, as I mentioned before, I have made a separate video in which I show you more details about how to find the outer foil and why it is important, and a bit of theory behind it. So go to my videos and check that out if you're interested. But now I will continue to to find the outer foil of all of the capacitors, which I have to as replacement, which I've ordered as replacement, and then I will replace them. Okay. Okay, so now I found the outer foil of all my replacement caps, and one interesting result here is that it is not always the same side. So if you look at this, the text is written in this direction. Here we have the outer foil on the right side. And if, for example, we take this one here, then you can see the text is in the same direction, but here's the outer foil on the left side. So you cannot just measure one and say, okay, if it's in this direction, then the outer foil must be here. It can be here or either here. So you have to measure each individual capacitor, okay? So, but next, I will now start replacing all the capacitors with this just a solder job. So I have to remove them and solder in the new ones. And I will do this right now, and I will be back as soon as I have finished that. Alright, so as you can see, I'm done with these capacitors here. There are these yellow capacitors everywhere, these beautiful yellow capacitors, so I've replaced them. And if we look down a bit, there we go. You can see here, these are all the old capacitors. So these are the old leaky capacitors which I have replaced. So we are almost there. We are almost at the point where we can turn on the device. But there's one more thing to do, and this is to replace the small electrolytic capacitors, or smaller electrolytic capacitors on the top side. Okay, so let's look at the top electrolytic capacitors. Okay, so here we are back at the top, and here we're looking at this electrolytic capacitor. So this smaller, actually they are not that small now compared to the new electrolytics here. They are actually quite big, and now I will replace them. And as replacement I have these capacitors here, and you won't believe it, but they have the same capacity, and they have even a higher voltage rating, so they are better than these ones, but they are much smaller. So here you can see that, yeah, electronic components get smaller over time, and most of the time this is not a disadvantage if you replace capacitors on such devices, because then you can always fit the new component in here, and you could in theory restuff them, so you can put these caps into the housing of this one, and it would look absolutely original. But I won't do that right now. I will figure out a way how I will mount it on here, and now I will replace them. Okay, so let me do that. Okay, alright, so now I've finished replacing these capacitors here. As you can see, they are really much smaller than the old ones, so they are much bigger. And to make the whole thing mechanically more robust, I've mounted them here onto this old mounting strap, so that if they are carry this device, or so that due to vibration nothing comes loose, so it's more robust, and it prevents that anything could be shorted out potentially or something. So this is one very important thing. And one interesting thing here is before I replaced the capacitors, there were two caps here, but now it's only one, and this is because the second cap was mechanically mounted, but there was no electrical connection, so they haven't used the second cap. It was just there, and so I don't have to put in a second one, because if it's not connected, then it's not needed actually. So now we are almost ready to turn it on. There's only one thing left, and if you can remember, we have tested these tubes, and we found that this one here was not working. This tube here, not even the filament was working, so the filament was just open. And now I can replace this tube, because I here have the replacement, and I will do that right now. So I will remove the old tube like this here. Okay, and now let me plug in the new one. It seems a bit bigger than the old one, and let's see. Okay, it is bigger, but this is not a problem. We can use this here, this shield. Yes, this fits. Yep, this fits on here, and I put this onto here, and everything is fine. Okay, so now the thing should be working. It should be in a working condition. And I don't think that I have missed anything, but we will find it out shortly. So now the next step is to connect it to the power grid and to connect the microphone to it and see if it actually works. So this will be quite exciting. So let's do that. Okay, alright, so let's test this thing. This will be very exciting. So to do that, I will connect my variable isolation transformer to it. So now it's connected, the transformer is still off. And now I turn on the power here and nothing happens because the transformer is still off. And now I will turn it on, and I hope that this lamp goes on, and this meter should read the line voltage. So it should be at 220, 230 or something. So let me turn on the transformer. So let's do it. Alright, okay, that's great. Now we see the line voltage here, and the voltage is at 200, a bit more than something in between 220 and 230. So this is great. The lamp is also on, and now hopefully the tubes should start to glow. And yeah, let's have a short look at the tubes, what they are doing. So let me turn off the lights, and as you can see, this tube is glowing, and these other ones, they're starting to warm up a bit. Yes, they do. So actually we have filament voltage here, and let's see if we have some, let's see what it does if we connect a source to it. Okay, so before I connect the microphone to these inputs here, I will check the inputs if there is any DC output at the inputs. Basically it shouldn't, because there's no phantom voltage, and if it's an input then there should be no output. But I do this to ensure that I don't damage my microphone. So I will use the multimeter and check all pins if there's any DC output. So I will start with, let's do it that way. Okay, that's fine. That's fine. So from here to here, that's fine. That's also fine. From here, nothing. And nothing. Okay, so this is fine. This is how it should be. And now we can connect the microphone and see if it is doing something. So for that I will use this cable, which is XLR to XLR, and then it connects to the device. And so I will plug it right in, right here. So I have to plug it into the right direction. So okay, and this can also be screwed onto here, but I won't do it right now because it should be stable enough. And now I will connect the microphone. Okay, so let's do that. And now turn on the microphone. Test 1, 2, 3. Can we hear something? Test, test, test. 1, 2. Oh yeah, we have something. You might hear it now that my voice gets amplified. We have output here. This is just great. Test, 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 test. As you can hear it, if I turn it even louder now, it starts almost to feedback. As you can hear now, it starts to feedback because it's very loud now. Okay, so this works. So the first microphone input works. Great. So let's jump right to the next one. Now you can hear I've disconnected it, and now this is the next one. And yes, so now we have connected it. And yeah, this as mentioned before, this regulator, this potentiometer regulates both inputs. Okay, test, 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 test. Okay, so the second input also works well. So let's go to the third one. So here. Okay, so now I've connected to the third input, and now I can regulate the output level with this potentiometer here, and it works also perfectly fine. And now let me try to switch. Now it's off, so I've turned it off, and now it's on again. So okay, and if I pull it, now it is less bass, so we have more treble right now. And if I push it in, now we should have more bass. So maybe you can hear this hard to hear now because you hear my voice coming out of this thing and you hear it directly. But anyway, let's go to the next one, to the fourth input. It's working fine. Okay, so we have repaired it. Amazing. So if everything here works, what we haven't tested so far is the line input here. So I will test the line input. I will just connect my function generator to it, and let's see, or let's hear if we can hear something coming out. Okay, so let's do that. Alright, so now I've connected my function generator to the line input of the device. I've set it to 1 kHz and a low amplitude, and let's see what it is doing. So let's look at the device. So as you can see, the function generator is connected to the line input, and I will switch the line input on right now. And as you can hear, it's working. The line input is working. This is great. Okay, so microphone inputs are working, line inputs are working. Okay, so this is just great. So we have repaired this thing electrically, so it's working pretty fine now. So this is just great. There's only one more thing which I will do. I will clean these knobs next. I will clean these buttons next, because I've already cleaned the potentiometers, but I will clean these switches actually. I will clean them, and then it's ready to use. And as I mentioned before, this thing will be used by Half-Baked Cheese. So if you want to see this thing in action, then check them out. In the description of this video you can find a link to their pages, and yeah, of course, check them out. And yeah, this actually concludes this video. So I can say thanks for watching, and bye.